Hey everyone, today we are discussing about introduction to linear regression, where linear regression is a supervised learning algorithm used for predicting continuous values. The core idea is to model the relationship between independent and dependent variables with a straight line, where the equation of linear regression is y is equal to mx plus c, where m is the slope and c is the intercept. This line is called line of the best fit. Linear regression is foundational in data analysis, forecasting, and predicting models. So, there are some types of linear regression. They are simpler linear regression, where it have one input variable, multiple linear regression, where it have two or more input variables. Equation of multiple linear regression is y is equal to b naught plus b1 x1 plus b2 x2 and so on. Simple regression is easier to visualize, while multiple regression works higher dimensions. These both types of linear regressions is to minimize prediction error. The choice is depends on the complexity of the data. And now let us discuss about how linear regression works. Uh, fits a linear regression fits a straight line that minimizes the error between predicted and actual values, which uses the least square method to fit the best line. Slope m indicates how much y changes with x. Intercept c is the value of y when x equals to 0, where it's highly sensitive to outliers. There are also axes which are x-axis and y-axis, where x-axis is independent variable and y-axis is dependent variable. Now let's see cost function and linear regression. The main purpose is it introduces how model error is measured. It uses mean squared error, which calculates average of squared errors. In this, we have lower mean squared error, which is used to better model fit. The cost function is minimized during the training period. It helps the model learn the best parameters. Mean squared error is always non-negative and easy to differentiate. Now, let us discuss about evaluation matrices. This evaluation matrices main purpose is it is used for judging model performance. For judging model performance, we have average squared errors, square root of MSC, which is more unpredictable, MEE, used for absolute errors, R square score, which is used to proportion of variance explained by the model. Higher R square means it has better fit. Each metric offers a different perspective and it helps to determine model quality and make. Now let us discuss about applications of linear regression. This linear regression used in real estate for predict house prices and stock market for trend forecasting. It used in healthcare for risk prediction and also used in agriculture for crop yield estimation. There are some more applications like manufacturing, retail, energy, etc. It is widely used due to simplicity and interpretability. Let us discuss about some advantages and disadvantages of linear regression. It is very simple and easy to implement, and it requires less computation. It is good for linearly separable data, and the limitations are it assumes linear relationships, sensitive to outliers, poor for complex data patterns, and not suited for the classification tasks. Now, let us see how linear regression works in practically. We are starting We are starting by importing libraries as NumPy for numerical operations, Pandas for data handling, Matplotlib to visualize data results, and then for generating synthetic data set, we are generating 100 random data points for a for a simple linear equation y is equal to 4x plus 3x. Then p dot random adds some random noise to stimulate real-world data. This represents a basic real-life situation like predicting house price from the size. Let us plot. Here we visualize the data using scatter plot. The points to show a general upward trend, which is ideal for linear regression. And now let us run this code and see this particular. particular cell defines that it prepares data for linear regression by adding a bias column to X, enabling the model to learn both slope and intercept. And then this particular cell explains that it calculates the optimal model parameters, which directly using the normal equation, a closed form solution for a linear regression. And now this view model parameters prints the model parameters obtained from the normal equation, and this contains small test values x equals to 0 and x equals to 2 to use a prediction. And this particular cell predicts the learned model parameters to predict the y values for the x inputs. And then this predicts y and x inputs, and then finally it plots the evaluates the model using mean squared error, which measures the average squared difference between actual and predicted values. Let's run this cell. This cell specifies that it sets the learning rate, number of iterations, and random initial parameter for the training model using gradient descent. And we get the output as intercept 4 and coefficients. And then this cell defines that it performs 100 iterations of gradient descent to gradually adjust the parameters to minimize the prediction error. And this predicts the final parameter from gradient descent to make prediction xy values, and plots the regression lined through gradient descent, showing that it fits the data similarly to the line from the normal equation. And these two cells defines as the R square to evaluate how the well model explains the variation in the data, a value close to the incident in a good fit. So this is all about simple linear regression. Thank you.